machine learning. All right, let's talk about object-oriented modeling. This is one of the most powerful technique in the software engineering, and you can use this technique to understand any sort of system. And the second advantage of this technique is that we have a programming languages which provide support for this technique. So what is the technique about? If you want to build a system, you get a requirement document from your client and you see a lot of features in the requirement document and you are overwhelmed. Oh my God, how can I implement all these features together in one single system? So the system seems very complicated, very complex. So what you do, you can apply this technique and you can make it very simple. And the cool thing about this technique is that you have a supportive languages like C++, Python, Java, or any other programming language which provides support for object oriented. So you can definitely use those languages, and those languages I've already discussed in my previous lecture. So since we have available support, we can definitely use this technique. So the technique as we break down the bigger problem into smaller concepts, which are also called objects, and then we can give a role to each object and we can represent each object in our computer world using those programming languages. So for example, a tweet and a Twitter could be considered as an object, and an object must have some attributes and some behaviors, right? So the attributes of the tweet may be the timestamp, the author, the text, the reviews, the replies. So these are some of the attributes of the tweet. Similarly, if you want to buy something using online shop, so the product that you see could be considered as an object, and the title of the product, description, prices, images, reviews. So these are what we call the attributes of the product. So that's how you can break down the whole requirements into multiple objects, and then you can give role to each object, like what an object can do and what should be the attributes of each object. And definitely you can then represent each object in a computer world, and you can design the whole system and you can develop it. So object-oriented modeling basically represents key concepts as objects in software. Objects can represent people, places, or things. Objects hold specific details which is called sometimes attributes, like person. A person must have name, age, gender, occupation. Similarly, a place, so the attributes of place may be name, size. An object, for example, object could be mobile phone, laptop, or any other device. So that device must have some dimension, some color. So these are what we call the attributes of the object. As I already talked to you that when you identify the objects and you give role to each object, so there must be responsibilities of each object. If you identify objects which has no responsibilities, so that object is of no value. So objects have behaviors or responsibilities. For example, a person can sit, can type, can go, can walk. So these are some of the responsibilities, and sometimes we call it behaviors. A device can power off, power on, and can display image. So again, these are some of the behaviors or responsibilities. Benefits of using objects and code. The code would be organized because you have identified all the objects, and each object has their own behaviors and properties. So if in case you want to change the behavior of any object, so you don't have to touch all the other objects. You can go and you can change the behavior of certain objects, and it won't affect rest of the code. Similarly, flexibility. The code is flexible. If somebody want to make changes, so again you can make those changes very easily, because the system is divided into objects, and removing an object or adding new object won't make that much effect for rest of the system. Similarly, reusable: once you design an object, you can reuse that object and other parts of the system. So objects are self-aware and software. Phone knows its specification, chair knows its dimension and location. In object-oriented thinking, everything can be considered an object, animate or inanimate. So there are two types of object. Animate are objects. So basically there are two types of objects. Animate objects are inanimate objects. So basically there are two types of object: animate objects and inanimate objects. And everything can be considered as an object, whether it is animate object or inanimate object. Animate object has a lifetime, while inanimate object has no lifetime. For example, the animate object would be a person, everything can be considered an object, whether it is animate or inanimate. Animate means living things, and inanimate means non-living things like chair, computer. Inanimate means like human, animal, etc. Alright, since this is one of the most powerful technique in software designing and architecture, so I want you to have a practice of object-oriented thinking. So the good practice would be view the world as objects with attributes. For example, if you go outside your house and you see a ground, a tree, a bike, a bus, so you have to identify all the objects, and then you have to give role to each object, like what should be the properties or the attributes of the object, and what are the main responsibilities of that object. So that's how you can improve your thinking and objects. For example, if you enter a room and you see a computer, and you start identifying all the attributes of computer, like what is the color, what is the size, what type of CPU it has, and then the responsibilities, like it is responsible for displaying the lectures, it is responsible for running the movie, and these are some of the responsibilities for storing data. Similarly, you see a person like a teacher standing in front of the class delivering a lecture, so you identify all the attributes, like what should be the name of the person, joining date, salary, and what he teaches. So these are some of the responsibilities, some of the properties, The responsibilities would be to teach a particular subject. Similarly, you see a furniture, chairs, table. So furniture is an object, and you start identifying the attributes and the responsibilities for the furniture as well. Each object has details, which is sometimes called attributes, and behaviors, which is called responsibilities. So I want you to identify some of the attributes for computer and some of the attributes for person. So for person, it would be like the name, the age, and the gender, CNAC, etc. Even the room itself can be an object, right? How the room can be an object? Does it have some attributes and some responsibility? Yes, it does. It has some attributes like seating capacity, room number, and it has also some responsibilities like provide space, host activities. So that's why the room is an object. The key idea is to train yourself to spot objects everywhere and think of their details and behaviors. Wherever you go, so you have to spot all the objects, and then you can give different roles to each object. In real world, literally, the system works like this. If you see, so you have different objects, whether it is a car, it is a truck, bike, or any other object you can have. That object must have some attributes, and that object must have some responsibilities, and it has also a lifetime. For example, you have an engine, that is an object, and that object is fitted inside the car. So if the car is destroyed, the engine is also destroyed. But that is something which we are going to cover later on with details. So for now, you just have to identify all the objects, you have to spot all the objects, and you have to identify their attributes and responsibilities.